experienced load shedding exactly at 12. So we are still fixing that, and then we shall be live. Hello, everyone. This is Awonke. Again, sorry for the delays. We experienced load shedding exactly at 12, and our ability to connect, which is the internet connection, the Wi-Fi, relies solely on the presence of the electricity. So we tried other means. Sorry for the delay. Okay, so today we are doing paper 2 again. We are proceeding with that revision as we did yesterday. We focused yesterday on Euclidean geometry and a part of trigonometry. So today we will be focusing on the last part of trigonometry, and then we dive into analytical geometry. So let's get into it. I think, let me mention again that it's important that you stop me in the middle of whatever that I'm saying if there is something that I said and you did not understand, or there is a question that you think is relevant to what I would be saying at that time, and you don't want me to move and go to something else to a point that your question is no longer relevant to what I would be talking about later on. So it's important that we engage. The more we engage, well, I assume the more we learn. So we dive into the trigonometric functions. Yesterday, we did other parts of trigonometry, such as the part whereby we simplify and stuff like that. Do you have a question?
No.
Oh, okay. Yesterday, we did other parts of trigonometry, where we simplify an expression. Now we dive deep into the trigonometric functions. For this part, you will need mainly your calculator. I don't have a calculator, well, a Casio calculator on my laptop that I can share on the screen for you to see. So I will call out a few words that you will have to look for from your Casio calculator so that you can follow what is it that we will be doing here. If you look on this question, which is 12 marks, it's an exam type question. I think this was written in 2012. No, I think 2020 or 2016, November. So it says in the diagram, the graph of f of x, which is 2 sine 2x, is drawn in the interval from x equal to 180 degrees to 108. So that is our domain, from negative 180 degrees to positive 180 degrees. So there is your sine graph. It has 2 turning points where x is equal to, well, it has 4 turning points, 2 at maximum and 2 at minimum. So at minimum, the y value is negative 2, and at maximum, the y value is positive 2. And it has 3, no, not 3, 1, 2, 3, 4, 5. It has about 5 x-intercepts. It has about 1 y-intercept. So if you look at it, it seems like the stepping here is 45 degrees from 0, 45, 90. What comes after 90 when you add 45? I think should be 135, 0, 45, 90, 135, 108, 0, 45, negative 45, negative 90, negative 180, all up to negative 108. So the domain from negative 180 to positive 180, the stepping seems like it's that of 45. Also, there are 4 turning points, 2 maximum, 2 minimum, 5 x-intercepts and 1 y-intercept. So these are the things that we observe from that given information. And then we are required in 6.1 to draw on the same system of axes of which f is drawn, to draw the g of x, which is negative cos 2x for x from negative 180 degrees to positive 180 degrees. Basically, they mean draw that g of x in the same set of x's and in the same set domain, in the same domain from negative 180 to positive 180 degrees. So then they instruct us to clearly show all the intercepts with the axis, that is x-axis and the y-axis, the coordinates of the turning points and the endpoints of the graph. Of course, the endpoints have to exist at the boundaries, at the beginning of the graph and at the end of the domain. So I'm using a Casio calculator. I'm not so sure if all of you do have a Casio calculator. I think some do use Sharp, which is not which is not equipped for this thing that we are going to do here. So when you sketch a graph, step 1, is to click mode. There is mode in your calculator, and then you will click the number that is next to table. I think there are three options that you have, which is comp, stat, and table. So click the number next to table. The number that I have on my calculator is 3, and it gives me sort of f of x is equal to. That is what I have on my calculator. So there I will write exactly the graph that I have to plot, which is that negative cos 2x. So I will say negative cos 2. So it's negative cos 2. And then when you want to write that x, you have to start from alpha and then click x. So here we use alpha when we write that negative cos 2. Before you write that x, you have to click alpha, and then you go and click x, and then you click your close brackets. So it's mode, table, and then you write the function that you have, negative cos 2. And then when you go to x, you have to start at alpha, click alpha, and then click x and close brackets. And then after that, you press enter, which is equal sign basically. You press enter, which is equal sign. Some of the Casio calculators will give you another function, which is g of x. In this case, we don't need it. So you can press enter again after you have received an expression of g of x, press enter. And at the moment, you should see something that says start. Look at the domain that you are given. The graph has to start at negative 180 degrees, or that domain that you are given in that question. X has to start from negative 180 degrees. So your start is 180 degrees. And then you press enter. It has to end. You check the domain again. It ends where? It ends at positive 180 degrees. You enter positive 180 degrees again, and then press enter. So every time you press a number, you follow by enter. Every time you press a number, you follow by enter. And then after you have substituted your end point, there comes a step. If you look at the graph that is already drawn there, which is on that Cartesian plane that you are given, it seems like the stepping is from 0 to 45 to 90 degrees to 135 to 108. So it's a step of 45 degrees. There are 45 degrees in between the points. Hence, the stepping then will be 45 degrees. And then from there, you press enter. 45, and then enter. Are we moving along together?
Yes, sir.
Yes, sir.
What did you get on your calculator?
There is a table which the first row is x and the second row is f of x.
Okay, what are the points?
For x is negative 180, negative 135, negative 90,
that's
negative
good.
45.
What about f of x?
F of x is negative 1, 0, 1.
That's good. That's good. That's enough. That's good. So let us plot then those points, and then we will join them to form a course graph. So that means if you look at those two columns, x is negative 180 and y is negative 1. X is negative 135. F of x is 0. X is negative 90. Y is 1, and so on. So that means we will go to our Cartesian plane. We sit there at negative 180. We check where is negative 1. And then we go a few units to negative 1. There is negative 1 on that Cartesian plane. That means there is a point there for this graph. Another one is negative 135. There is negative 135. There is a point there because y is 0. Basically, this is an x-intercept. So we have another point there. Another one is x equal to negative 9. What is y on your calculator when x is negative 90?
Positive 1.
So we will go up to a point whereby we reach positive 1, and then we have a point there. We have a point there. And then what is the next one?
And then x is negative 45, and then y is 0.
Yeah, which means this is the x-intercept, right? There is the x-intercept, and so on. So now I will just fill in those things. Y is 0, x is 0, y is negative 1, x is 45, when y is 0, that means we have a point over there. Y is 90 degrees, and x is 90 degrees, f of x is 1. X is 135. If x is 135, then y is 0. And that means we have an x-intercept there. When x is 180, what is y from your calculators?
Negative 1.
Negative 1. So there is 180, then we go down and check for negative 1. So we will then join that graph. Remember, this is a cosine graph. So a cosine graph does not just like go like a sort of a sine. A cosine graph is different when it begins. A sine will just go up like that and join points, but a cosine graph will start as a cup shape. I don't know whether you have noticed this before, but that is what cosine does. It starts as a cup shape. It does not just move from one point to another in a sort of a straight line manner as sine does over there. So that means we won't have a line that joins like that, because this is a cosine graph. We will have a sort of a cup shape at the beginning, and then we take it from there. Even at the end, we expect to have a sort of a cup shape there like a, I tried. So this is what we mean by drawing f of x, that is, not g of x, that is our g of x. So it's quite easy. Well, in my view, it's quite easy. And it can be easy for you as well, because you just follow these simple 7 steps. You press mode, table, you enter the function, you enter the start, you enter the end, you enter the stepping interval, then you are done. Are there any questions with regards to what we have done?
No question.
We move to the second question, 6.2.
No question.
Okay, that's good. Let's go to 6.2. In 6.2, they say write down the maximum value. We want the maximum value of f of x. We want the maximum value of f of x minus 3. What do you think we should do there?
Equate the formula to -3. Oh, no, it's -3. Oh, shit. Sorry. I think it should say f of x 2 sine 2x minus 3.
You want us to say the maximum value of f of x will be equal to 2 sine 2x minus 3, and then
Excuse me, sir.
sure.
This is Nande here. Aren't we supposed to put the x minus 3 in brackets?
X minus 3.
Yeah, in brackets, or do you just leave it like that as 2 sine x minus 3?
That minus 3 is not part of x.
It's not part of x.
Yeah.
Okay, so you leave it like that.
No, we are not done. I'm just waiting for the guy that gave us the idea to explain further. We are not done, and we have not confirmed yet whether it is the correct answer. Okay. I'm just waiting for the guy to come through and explain further.
Sorry, sir.
Sure.
Who can't join the live? They're saying that the host is not letting them in.
Ooh, okay. Very interesting. The host has left the live though. I will stop sharing the screen so that I can go and accept the person and then come back. Is that fine?
Yes, sir. Thank you.
I think let me just go and accept. But I can't see any person that is trying to join though. Oh, there they are. Okay. Okay, this is how you answer this question, right? Because they say they want the maximum of f of x minus 3. First, we have to know what is the maximum of f of x. And then from that maximum, we deduct the -3. That means the graph now is being shifted 3 units down. The graph of f of x is being shifted 3 units down. That is what is happening there. So what is the maximum of f of x? There is f of x.
2. Positive 2.
So we'll have a +2 minus 3. So let us check from there. There is +2. We shifted this graph 3 units down. Let us see what is going to happen. 1 unit, the maximum now is 1. We drop it down by 1 unit again. That means the maximum now is 0. And then we drop it 1 unit again, which is for the last time. What will be the maximum in this case?
-1.
-1. Let's see if we will get -1 here. What is 2 minus 3?
-1.
-1. So that is what is happening here. You drop the graph of f of x 3 units down. So if there was a plus here, not a negative, that would mean we are dropping, we are not dropping, we are lifting the graph 3 units up. Is that fine?
Yes.
Okay. Now let us go and determine the general solution. I think there's a person that is unmute. Can you please unmute yourself? Can you please mute yourself? Because the background noise. Oh, thank you very much. So now we are at 6.3, which means we are determining the general solution of f of x is equal
Excuse
to,
me.
okay.
For 6.2, I still don't understand what we did exactly to get the maximum value of that expression.
There.
Yeah.
Okay, thank you very much for stopping me there. I like questions. They say they want the maximum value of f of x minus 3. So if you have an expression of that form, that means there is some shifting that is happening there. If that 3, it was, let's say, 30 degrees and it was part of that x, that would mean that the shifting is horizontal. They shift the graph either left or either right. But now that x is not part of, that 3 is not part of the x, so that 3 is outside the brackets. That means then the shift is not horizontal. It is actually vertical, up and down, up and down, up and down. So if the shift is up and down, you decide whether it's up or it's down by that sign you have there. When that sign is negative, that means the graph is being shifted downwards 3 units. If that sign is positive, that means the graph is being shifted up 3 units. So that is what is happening there. So in order to determine the maximum value of that expression, we have to substitute in the place of f of x by the maximum value of f of x. That is what we are going to do. To get the maximum value of f of x minus 3, we have to substitute at f of x by the maximum value of f of x. So where is the maximum value? There is f of x. What is the maximum value?
It's 2.
The y value there at the turning point is 2.
Yeah.
Hence, we are going to substitute a 2 there. And then we say 2 minus that 3 that was already there. 2 minus 3 is equal to a minus 1. So the maximum value of that new expression will be a negative 1. That means the graph shifted from positive 2, 3 units down to a negative 1. So the maximum value now is at that point, and the maximum value is at that point. So we shifted the graph 3 units down from 2 to 1 to 0 and to negative 1. So that is what happened there. Is that clear now?
Yes, thank you so much.
Very well. Another thing. Oh, well, now let's move to the general solution. So when we want to determine the general solution of that expression, f of x is equal to g of x, we will have to substitute in the place of f of x by f of x, and that is 2 sine 2x is equal to, and then we will have to substitute in the place of g of x by negative cos 2x. So if you look at that, there are two trigonometric expressions in that equation, and that is not a good thing. At the end of the day, we have to convert these trigonometric expressions, these trigonometric ratios, such that we only have one trigonometric ratio. Before we determine a general solution, we have to reach a point whereby on the right-hand side, we have a trigonometric expression, trigonometric ratio, basically. And this trigonometric ratio should be equal to a constant. So that is where we want to get to. Your trigonometric ratio, just one trigonometric ratio, equal to a constant. That is what we have to get to. And then from there, we start determining the general solution. So the thing that will take us from where we are now, from that stage where we are now to that stage that we want, which is where we have a trigonometric ratio on one side and a constant on the other side. The thing that is going to take us there is through simplification and factorization from algebra. And then from there, we get to a trigonometric ratio on one side and a constant on the other side. And then when we get there, we can start determining the general solution. So that is what we have to do. We will do simplification here, factorization, we substitute our trig identities and stuff like that. So if you look at what we have here, we have a cosine, well, a double angle of cosine and a double angle of sine. These two trigonometric ratios are different. That's a wrong thing. Well, that's a bad thing. So let us make them one thing. The good thing here is that as much as these two trigonometric ratios are different, but they have same angles, which is 2x, 2x. That's a good thing. That means somehow we can divide and stuff like that. We can factorize and stuff like that. So when we have sine and a cosine and there is no square, when there is sine and cosine and there is no square on one of the two, we might want to change it to tan, because the trigonometric identity that combines sine and cosine is tan x. So tan x is equal to sine x over cos x. That is what we studied from grade 11. So if you observe at this expression of tan, it combines sine and it combines cosine at the same time. And this cosine is at the denominator, and these two angles are the same. And the cosine is at the denominator. So if we want to form a cosine, if we want to form a tan there, which trigonometric ratio should we divide with?
We should divide by cos.
Why do you think that we have to divide by cos? What's your thinking process?
Because sine divide by cos, it will give us a tan.
We need to divide by.
But according to my knowledge, I think you should start by dividing by -1. I don't know if I'm correct or wrong.
Why do you think we have to divide? Why do you think it's necessary that we divide by -1 first?
In order to get rid of negative cos.
Get rid of negative cos or just the negative?
Actually, the negative.
The negative is a problem. How?
But okay, sir, let's proceed. Let's proceed. I wanted to see something.
Sir,
Sure.
how about we divide through by negative cos 2x on both sides, and then on the left-hand side, we will be left with 2 tan 2x, and then on the right side, it will be -1.
So do you
Positive
want us
one.
to do you want us to divide by negative cos 2x or just cos 2x?
Oh, then it will be +1 if we divide by negative cos 2x on the left-hand side.
So you want us to divide by negative cos 2x?
Yes.
Okay, that's why do you want us to divide by the negative? I get the part of cos because we want to turn it to tan. But what is the problem that you have with the negative?
It'll just be easier to solve, I guess.
Okay. Now let me accommodate you guys and divide by negative cos 2x. I think it's fine, basically. It will get to the same answer at the end of the day. So we divide by, can I just go quickly and check if there are people waiting?
Okay, no problem.
Okay. One person, okay. Thank you. I think that was for last time. 15% and there's no electricity. That's interesting. So let us divide it then by negative cos 2x, negative cos 2x. And then on the right-hand side, we will be left with the positive. On the right, yeah. We will be left with the +1, right?
Yes.
Yep. Okay. What will be left on the left-hand side?
-2 tan 2x.
-2 tan
2x.
Tan 2x.
Yes.
What is next?
We divide by -2 both sides.
You see, you divide by negative again. That means you take that negative that you took from the right, you took it from the right, you took it to the left. Now you're taking it from the left to the right, which means it was right initially there on the right.
So,
sure.
But the main reason why we divide by negative cos 2x in both sides is because what you do on the right-hand side, you must also apply to the right-hand side. That's why we accommodate that negative.
Now let's proceed.
Let's proceed. We are taking nonsense.
So we will divide by -2. We will divide by -2, and then we get tan 2x equal to a -½ So that is the expression that we wanted. Do you still remember that we wanted a trigonometric ratio on the left and a constant on the right, or a trigonometric ratio on one side and a constant on the other side. And then now we're at a stage whereby we determine the general solution. That is where the general solution begins now, whereby we determine the reference angle. How do we determine the reference angle? You press on your calculator, shift, and then you press the trigonometric ratio that you have, which is tan in this case. Which value do you think we should substitute on those brackets? Because we will have sort of tan -1. Which value should we put here?
1/2.
1/2. Why do we leave the negative?
The negative determines where tan is negative. We don't punch it on a calculator.
Yep, we do not use that negative because that negative over there will give us the quadrants. So you do not use it twice. Do not use it for quadrants and use it for the reference angle at the same time. Your answer will be wrong. Use it once and use it only for determining quadrants. So over there, we will substitute a half. I think your answer should be 26,57, if I'm correct. What does your calculator say?
Yeah, same here.
26,57 degrees. So which quadrant is has negative? Which quadrant where tan is negative?
2 and 4.
Yeah, that is quadrant 2 and 4, where tan is negative. So that is what we are going to do now. We will deal with the second quadrant on this side, and then we will deal with the fourth quadrant on the other side. Hello?
May you please go back to the reference? I didn't hear you well.
Oh, okay.
I didn't understand.
Okay, no problem. We say here, when we get to this point where we have a trigonometric ratio on one side, a constant on the other side, that is where we begin the general solution. Everything else was just simplification and factorization. Now we begin the general solution. And when we begin it, we begin by determining the reference angle. The reference angle, you will determine it on your calculator by pressing shift. There is shift on your calculator. So after pressing shift, you will press the trigonometric ratio that you have, which is tan. And then after pressing tan, you will receive an expression of tan -1 and the brackets. What am I doing? Okay. So after pressing that shift tan, you will receive an expression of tan negative and then open brackets. We say when you get there, the value that you have to substitute is the positive value of that constant. As we have a negative half there, we are not going to use that negative. We are going to use that half. We will use only the half, the positive value of that constant. The reason for that is because the negative, or whether it's positive, the sign that is there will give us the quadrants of that tangent that is there. So we know that tan is negative in 2 quadrants, which is the second quadrant and the fourth quadrant. So this negative tells us that we will use the second quadrant and the fourth quadrant, not the 2 quadrants. We will use the second and the fourth. So that means we have used then that negative. Let us not then use it twice. Let us use it only once. So hence, when we substitute over there, we only substitute that positive value of the constant, not the negative as well. And then you press equal sign in your calculator. You should get a 26,57 degrees. Is that clear now?
Sir?
Okay.
I'm not getting 26. I'm getting 29 on my calculator.
You're getting 29?
Yeah.
Can you read what is on the screen of your calculator?
It's 29,516, so it's going to be 29,52 for me, and not.
No, not the answer. No, do not read the answer. Read the
Oh,
one
okay.
that is.
It's
Yeah.
shift. I pressed shift 10, and then I subbed in a half. Press equal.
Very interesting. Yeah, that's very interesting. Can you press cancel and press it again? I don't know whether you will be able to see this because this is what I have.
I'm not getting that, sir.
Very interesting.
Nope.
Is your calculator in degrees or radians?
I think it says G. Is that gradients?
That is, yeah, that's fine. Should be fine. No, I don't know where's the problem. Probably a calculator error. Never heard of that before, but we can cook names, I think. Yeah, on my side, it is 26,57. I don't know what happened, really.
I think it's a calculator.
Yeah, calculator error. Are you fine if we proceed with the way we are doing
Yes,
at the
sir.
moment? And then I think off the air, we can take a look at your calculator and the functionality of it.
Yes, sir.
Okay. So we said the turn is negative in the second and the fourth quadrant. So we will deal with those two quadrants. Now we take that 2x, the entire 2x.
Excuse me, sir.
Okay.
At school, we were taught that we can only use two quadrants when it comes to tan. And then so if it's positive, then we can use the first quad. And then if it's negative, then we use the second quad.
You started by saying you were told at school you can use only two quadrants for tan.
Yes.
So you can use only two quadrants for tan. Is that correct?
Yes, that's what we were told.
So that is what you are saying.
Yes.
For tan, you can use two quadrants. So where
You can
is
only use two quadrants.
Two, right?
Yes, just two.
And you are saying after that, what are you saying after that?
Yeah, just basically that.
The thing, no, I don't get your question because we have used the two quadrants.
No, as in like when it involves tan, like the general solutions, we can only use two quadrants. Therefore, if it's negative here, then we can only use the one quad, which is this is second quad.
Oh,
and if it is positive,
they said we have two options to choose from. Oh, okay.
Yes, basically.
Which are?
Which is the first quad and the second quad, if I'm not mistaken. Yeah.
No, that's new to me. I think
does anyone else know that?
Yeah, I think let us consult everyone that is here. Most importantly, the mathematics facilitators. Whether you're a tutor or a teacher, can anyone join this discussion? Because that's new to me. Really.
Yes, sir.
Hello?
That misconception, there's no such. All we know is that the tan is positive in third and also first quadrant, and it's also negative in second and also fourth quadrant.
Okay.
I think she's trying to explain this.
Yeah.
Wait, can I ask a question? Are you trying to use the concept where they're like, for 10 we can only use 180? So is that what you mean?
No, babe.
I don't get your question.
Okay, let me explain something.
Yeah.
In trigonometry, you don't have to cram or you don't have to memorize. You have to draw a Cartesian plane and also label your reduction formula so that you can see when tan is negative. You don't need to cram.
Yeah, I know.
Okay. No, I think let us get the insights from the facilitators. Are there any facilitators in the lesson?
I don't think so.
So they are all learners.
Yeah, but I am professor.
No, that's new to me, to be honest. I've never heard of that. That's actually new. No, that's
Okay,
new.
but
Even I think, okay, let us do it this way. I think this question paper was written in November 2016. So go and download the memo for this question and see how many quadrants did they use. And
okay,
also
I'll check
check
that
other
out.
question papers and other textbooks. Check for general solutions
What year
where
is it?
tan. Hello?
Sorry,
Okay.
what year is it?
Eva.
Okay, what is happening now? November 2016. Okay, I don't know what is happening with my stream. That's very...
I think it's proper to proceed, so then they can follow seeing how it is done.
Sorry, you were saying something?
I think it is proper to proceed so that they can follow and see how it is done.
Okay, it seems like I lost connection on the device that I used to write on. So I'm trying to get that back. That's very interesting. So let us keep debating about this topic. About the use of, okay, I think I'm back at it now.
Sir.
Okay. Technology. Flames. I've started sharing the screen. Can you see something?
Yes, we can, sir.
Wonderful. Yeah, I'm sorry about that. It's technology, not me. So you were saying something?
Okay, so yeah, they do use two quads. And I'm guessing it's the first one, and I mean it's the second one and the fourth quad. And
so
then
the memo says that.
Yeah, but then if you look at it, it only gives 1 mark to an answer. So I don't think it's necessary to have the other answer of the other quad. But if you wanna be safe and everything.
The thing is, how do you decide which one to pick out of the two? The ones where, well, you said, okay, first and second quadrant, okay.
Yes. But
it's quite interesting because the general solution of this question, we're going to use it in 6.4. So
right.
when you've used one quadrant, you might be in a scenario whereby you are not able to answer 6.4 fully.
I think we will, because I think it's one of the same thing. Yeah, but anyways, it's fine.
Sorry to interfere, Mara. Can we proceed, guys?
Okay. Now I think let us proceed with the two quadrants. That's what I know, two quadrants.
Okay.
So we take exactly that 2x over there, and put it in that under second quadrant. 2x is equal to the reduction formula that we have in second quadrant.
180.
Yeah, 180 degrees minus x, and our x is the reference angle, which is 26,57 degrees plus k 180 degrees. 2x is equal to, what is 180 degrees?
153,44.
153,44 plus k 180 degrees, and then you divide by 2. When you divide by 2, you divide the first term, which is 153,44, and then you get a 76,72.
Yes.
Plus, you also divide the second term as well, which is k 180 degrees. So that will be 180 divided by 2, and that is 90 degrees. So that is what we get for the second quadrant. Then we go to the fourth quadrant. Again, 2x. Fourth quadrant, we have 360 degrees minus our reference angle, 26,57 degrees, plus k times 360 degrees.
Why 360? You are wrong, sir.
Okay, what should... Oh,
it should be 180 since the period of turn is 180.
Yep. That is 180 degrees. My mistake there.
Okay.
And then we say 360 degrees minus 26,57.
3,44.
3,43. I get 43 from my side.
43.
Yeah, it's 43.
Plus k 180 degrees. And then we divide by 2. What do you get? I get 166,715 degrees. Plus k times 90 degrees. And then what is left? K is the element of those things, integers. That has a mark, so you shouldn't leave that thing behind.
Prof, could you please mute your microphone?
Thank you. Thank you very much. So are there any questions with regards to how we determined the general solution? Well, besides the issue of the quadrants to use. Okay, let's move to 6.4, where we have to determine the values of x, where f of x is greater than, well, less than g of x, where f of x is less than g of x. Firstly, we have to know what we mean by f of x less than g of x. They actually mean a region where f is below g on the graph. We have to look in that region where f is below on the graph. That is why I drew g of x with a red color so that we can see clearly which one is g and which one is f, and which one is below the other and which one is above the other. So we will have to determine a region where f of x is below g of x. So where f of x is below g of x, that means f of x is less than. Something that is less, it is something that is below. For example, in a number line, 4 is there, and then 2 is there. So on the left, that is where we say 2 is below 4. So let us check where G is above and f of x is below, something like that. We want something where f of x is below, g of x is above. We check for that region. I will start. If you look from 180 degrees, we move there along f of x to that point of intersection. And if we start at 108, negative 108, we move following g of x, and we get there at that intersection. In this region, what is happening there? Which one is below the other?
G is below.
G is below f of x. Is this the region that we want?
No.
No, we do not want this region because g of x now is below f of x. Tina, we want a region where f of x is the one that is below g of x, which means f of x is less than g of x. Can you please unmute your mic, Prof? Thank you. So let us then move from that point of intersection because things stopped there. Now from the point of intersection, we check that the red graph, which is g of x, to that point of intersection. Intersection to intersection. There is g of x, and then there is f of x. In that region, from that x to that x, what is happening there? From in that region, which one is below?
F is below.
F is below, and that is what we want. We want f of x to be below g of x. So this starts where? We should be mindful of that as well. This starts at that point of intersection. So we must know what is the x value at that point of intersection. And it ends in that second point of intersection. So we should know what is the x value in that point of intersection. And then when we know that x value, we can determine the region where f of x is less than g of x. We will say x is in the interval from the first x-intercept to the last x-intercept. So how do we get that? How do we get those x-intercepts? There. We go back to the general solutions that we had earlier, which is x is equal to 76,72. X is equal to 76,72 plus k times 90 degrees. Let us write, and the second one is 166,715, 166,72 basically, plus k times 90 degrees. So now we will write the points of intersection from that point, and that point, and that point. So there are 4 x values where this graph intersect. These two graphs intersect. There are 4 x values. So to determine those x values, we have to use those 2 equations from the general solution. We have to use those 2 equations from the general solution. So let us start with the first one. Here we will write the set of x values where f of x and g of x intersect. We will use the first one, which is 76,72 plus k. In the place of k, we will just put 0. And then after putting 0, we determine the x value. And then we use 1, we determine the X value, we check if it is within that interval or what. If it is within that interval, we write that X value, and then we go up, we use K equal to 2. We check the X value is within that interval between minus 180 to positive 180. And then if that X value is not within the interval, then we stop going up with the K value. We go to negative 1, we go to negative 2, and so on. So the K values that we are going to use is 0, 1, 2, 3, and so on. Negative 1, negative 2, negative 3, and so on, the values of K. If K is 2, we get a value that is outside the interval, then we will not go up anymore. If at K is equal to negative 2, then we get a value that is not within the interval, then we will not go down anymore. So that is what we are going to do. 76,72 plus, in the place of K, we substitute 0. We press equal sign. We get X is equal to 76,72. Is that X value within the domain that is given? Hello?
No.
No, the domain is from negative 180 degrees. Oh, okay, from negative, there is the domain that is given. From negative 180 degrees to positive 0 degrees. So that X value is not within the interval. So let us then use, there's no need for us to go to, let us use 1. 1 gives us 166,72, and that is not in the interval. We want negative values. So let us substitute negative 1. For negative 1, I get K is equal to negative 13,28. Do you get that as well for K is equal to negative 1?
Sir.
Sure.
Yeah, I'm totally lost. There's no other method that we can use.
As far as I know, no.
I was trying to solve it inequalities, but I got no luck.
As far as I know, no. So the X value there in that turning point, just after the y-axis, is that negative 13,28. This is not K, it's X. And then we check for another X value, we use K equal to negative 2, and then we get a negative 100 and negative 103,28 degrees. There's a reason why that question is the last question in that question. It's a little bit of a higher order question. So that negative 103 is within that interval, and that occurs where just after the negative 90 degrees. That is where they intersect.
Sir.
Hello?
Please explain how you got to this point. I'm a little bit lost.
Oh, okay. You see, I used the first equation from the general solution. Maybe what makes you guys lost is this new color that I'm using. Let me use black again. So there is X is equal to 76,72 degrees plus K. So in the place of K, we said we will substitute a variety of numbers from 0, 1, 2, 3, and stuff like that. So the first thing that I did was to substitute in the place of k by 0, and then I pressed a calculator. I got x is equal to 76.72 degrees. And I checked the interval that we are given. I see that it's only negative values from 0 to negative 180 degrees. So that means that 76.72 is not part of that interval. So I should not use that k is equal to 0. Let me use another k. It can be 1, it can be 2, it can be 3. But I see that if I go to 1, I will still get a positive x value if I put 1 there. So let me then put the negative 1 and see what will happen. I substitute a negative 1 and see that I get x is equal to, when I substitute there with a negative 1, I get x is equal to negative 13.28. Did you get that value?
Yes, sir, I got that value.
Okay. And then we check whether this x value is within the given interval in that question. Do you think that value is within the interval or not?
Yes, sir, it's within the interval.
Yep, it is within the interval. And then that means that x value is the one that is there just after 0, because we move from 0, negative 49, negative 90, negative 135, negative 108. So that negative 13.28 is supposed to be there. And then there is the intersection. So this negative 13.28 is valid. So I did get that value, which is correct. Let me then look for the second one, because there are two intersections here in this region, from negative 180 to a 0 in that region. There are two points of intersection. So I am at k is equal to 1 now. Which other k do you think we should try? Hello? Which other k do you think we should try?
2, negative 2.
Negative 2. We should try negative 2. Someone at the inbox answered and said we should try k equal to negative 2. That is absolutely correct. So we try there, k is equal to negative 2. We press our calculator. What do you get from your side? Should be negative 103, comma what?
28.
28
degrees. So we check now if that x value is within that given interval. Is it there? That x value is between negative 180 degrees to 0. Yes. So we keep that x value as well as one of our x intersections. So there is that x value just after the negative 90 degrees. So there are no other intersections that we can find. So there's no reason to go on and change the values of k. So we know that the x value there, the x value in that intersection is negative 103.28, and the x value in that second intersection is negative 13.28. Now we have to answer this question, determine the values of x for which f of x is less than g of x, which is f of x is less than g of x, that is where f is below g of x. There is f is below g of x. This happens from x is equal to negative 103.28 to negative 13.28, negative 103.28 to a negative 13.28. So that is what happens. How do we then write this as the answer? We say x, you can write it as x using that interval, that sort of a notation. On the right, you write negative 13.28. On the left, you write negative 103.28 degrees. Or you can write it in that notation, x is the element in that interval, negative 103.28 degrees, all up to negative 13.28. The reason why there is no or equal pi in that note, in those inequalities, it's because the question itself does not have an or equal sign. Can you see that? The question itself does not have an or equal sign. So that's why we do not have an or equal sign even in our notation. So we will clean that one out. Another thing, the reason why this is not written as with those square brackets, the reason why we use the small brackets is that there is no or equal. So if there was an or equal, then we would write those square brackets, but now there are no or equal. Are there any questions? That was a good exercise. Did you finally get how we got the values of x? Because I think the confusion was there.
Yes, sir.
Okay. I think we should move then to what we call as two-dimensional and three-dimensional problems. Two-dimensional and three-dimensional problems. And then this is the last question in trigonometry. We will then go to analytical geometry. Analytical geometry is most of the time not so hectic for learners. It's a little bit easier than the two chapters, trigonometry and Euclidean geometry. So here, this is a question of 10 marks. I think this was in 2016. Yeah, November 2016, 10 marks. So we are given a landscape. They say a landscape artist plans to plant flowers within two concentric circles around a vertical light pole PQ. So there is PQ. Again, this is one of the. This is where you would use that thing we said in Euclidean geometry to analyze the question, the statement properly, because a lot of things here lie in what we are given in the statement. It's not like whereby they say determine general solution. That's easy. Well, it's not so easy, but it does not need a lot of what is said in the statement. Whereas here you have to analyze bit by bit everything that is there, make sense of it before you go to the questions. So that is what we are going to do. We are told that PQ is a pole, a vertical pole, which means it will be perpendicular to the ground. And then we are told that this is a ground where this landscape artist plans to plant flowers. We are given two circles, the small circle, and we are given the other circle, which is the bigger circle. And then we are told that this landscape artist plans to plant flowers within, that within is very important, within two concentric circles within. So something that is within is something that is within two things is something that is in between, basically. If there is a ball here, and then there is another ball there, and then we tell you to go to stand within those two balls, then you will go and stand in between of those two balls, basically. So if there is a road there, and then there is grass on this side, there's another grass on that side. So if they say walk within within those spaces that have grasses, basically you will walk between those regions. So what is it that they mean when they say to within? He plans to plant flowers within two concentric circles. Do you think he's going to plant in that, I don't even know that color. Let me use a color that I know. Me and colors don't mix. That, do you think he's going to plant in that red region, or he's going to plant in that black region? What is your guess?
The black region.
Yep. He's going to plant in that black region because he wants to plant within
Abu. Woo.
Huh?
No shedding.
Please, battery died.
Load shedding. Hello.
What happened?
Load shedding.
Maybe it's load shedding.
There's no electricity in Kabeja.
It's from Tsandani. Yes, man. Say.
Hello.
Somebody there? Hello.
Ooh.
Hello, guys, can you hear me?
Yeah,
don't.
Yeah, boy.
No, sure. Hey. Very interesting.
ESCOM.
Yo, you know how it goes.
Is it ESCOM, sir?
Yeah, the thing is we do not have electricity. So I was using the tablet for writing and I was using the laptop for the camera and the microphone. Now the laptop died.
Yes.
So I had to do things and maneuver around and finally shift the microphone to this device that still has battery. It seems like it's at 15%.
No.
Yeah, no, it's hectic. So we will push
Till it dies.
this one, but there will be no camera this time around. Hell, please come.
Yes.
It's part of being here. Anyway, sorry guys about that. I didn't anticipate it. Let's move forward. So they say the landscape artist plans to plant within flowers. So we have established that within is actually the part that I'm writing with a black line. So he wants to plant there. That is what he wants to do. Okay. I think there's someone that is unmuted. They say R, which is over there, is a point on the inner circle. Okay, we can see that. And then they say S is a point on the outer circle. Okay, we can see that. And then R, Q, S lie on the same horizontal plane. Okay, that RQS is on the same horizontal plane. And then RS is the pipe used for irrigation system in the garden. Remember, the garden is between that walk or dry walk there. So the pipeline for irrigation crosses that path from R to S. So that is the pipeline. Then the radius of the inner circle, there it's given as R, that is clear. And then the radius of the outer circle is QS, that is fine as well. That means Q is the center of the circles, that is fine as well. And then the angle of elevation from S is 30. Okay, that is fine as well. And then we are told that the angle there, RQS is 2x. And then PQ, which is the pole now, is given as 3R units. 3R units. Remember that R is the radius of the smaller circle. Are there any questions with regards to what we are given? Remember, analysis of that is very important. So you have to understand it. Are there any questions? So we will move very quick because my device is going to die 13%. They want us to show that QS is equal to 3R. So we have things that we have to notice here. They want us to show QS. So where is QS? There is QS. We can find QS in that triangle that is in the horizontal surface. And that triangle has R and it has 2x. We can also find QS in that vertical right-angled triangle. And that vertical right-angled triangle has a 30. And it has that root of 3R. So now we have to decide between this triangle that is in the horizontal plane, which has QS, and the triangle that is standing vertically, which is that right-angle triangle. Which one should we use between the two? We have to decide. Most of the time, the hint is given on what you want to prove. Because we want to prove 3R. So you might look at at these two triangles and check which triangle has 3 and also has R. Which triangle has these two things? There is 3 and there is R. If you look at the triangle that is in the horizontal plane, there is R, but there is no 3, which now sort of eliminates that triangle in the horizontal plane as one of our options. because it has a missing value of 3. And the vertical right-angled triangle has an R and it has a 3, which makes then this triangle a perfect candidate to prove that QS is equal to 3R. So that is how we get there. The reasoning process is very important. And now we have to decide which, because this is a right-angle triangle. In a right-angle triangle, we use the definition of sine, the definition of cos, the definition of tan. We have to use between sine and cosine and tan. Which one should we use? So that QS, sorry, is tan, right? Yes. That QS is the adjacent side of that angle, 30 degrees. Also, that side that we know, which is the root of 3 times R, that side is the opposite side of that 30. So we have an angle, the opposite side, and we wanted the adjacent side. So we ask ourselves, which trigonometric ratio combines opposite and adjacent at the same time? And we have established that it is actually tan. So we will say tan 30 degrees is equal to the opposite side, which is equal to the root of 3R divided by QS. Tan 30 degrees, which is tan of that angle, is equal to the opposite side, which is PQ, which is root 3 times P to the root 3 times R divided by QS. There is QS, which is the adjacent side. Then we say QS is equal to the root of 3 times R divided by tan 30 degrees. Press on your calculator, what do you get? What is tan 30?
Is it 3?
What is tan 30?
Oh, tan 30.
Square root of 3 over 2.
So
Yeah.
tan 30 is root of 3 all divided by, we can write it using that manner, root 3 over 3. So now you press only the numbers inside the calculator. Sorry? Hello? You press only those numbers in your calculator. What do you get?
3.
3.
Yep, that will be 3 times R. So we are exactly where we wanted to show. And the thinking process is very important of how you get there. So guys, if it happens that I stop talking and you see nothing, just know that the device has died. There's no battery and there's no electricity. I can't charge it. So it will be advisable that you exit. So we have proven that one. Are there any questions? Is it clear?
Yes, sir.
Yeah.
Okay. Then we are required to determine the area. We want now the area in terms of R, where this plant will be, these flowers will be planted, the area of the region that will be used for planting. we want to determine in terms of R, the area of the flower garden. Remember, the area of the flower garden is that black thing there. So the way we calculate the area of that region is that we calculate the area of the bigger circle, and then we subtract the area of the smaller circle, and then we are left with that area. It's like saying that the area of the bigger circle is 10, and then we are not going to plant anything in that area of that small circle. So if that area of that small circle is 2, that means if we are not going to use it for planting, then let us subtract it in the area of the bigger circle to get the area that we will use for planting. That is 10 minus 8, which is 10 minus 8, which is 2. That is if the area of the small circle is 10, and if the area of the big circle is 10, and if the area of the small circle is 8, then the region that we will use for planting has an area of 2. That is how we get there. So let us then determine this area. We say that this area is equal to the area of circle 1, which is the bigger circle, area of bigger circle, the area of bigger circle minus minus the area of the small circle. Remember, the area of the bigger circle is pi r squared. In fact, the area of a big circle, the area of any other circle is pi r squared always. And then we say negative. So within those brackets, we will substitute the area of the big circle. We will substitute, the radius of the big circle minus pi, and then we substitute the radius of the small circle. The first formula is the formula for the area of the bigger circle, which is pi r squared. We have not substituted that r there. That will be the radius of the bigger circle minus pi r squared. That r there is the radius of the smaller circle. So what is the radius of the bigger circle?
2x.
Sorry?
2x.
The radius of the bigger circle?
3r.
Yeah?
$3R.
The radius of the bigger circle is what? QS. Did you say QS?
$3RQS, same thing.
There it is written in the statement. They said the radius of the outside circle is QS. So that is why I wrote QS there. What is the radius of the small circle?
QR.
Just R, right? QR. And in units, it is QR. Or in fact, let me just substitute letters for now. QR. So the area of the bigger circle, pi q squared, qs squared, minus the area of a small circle, pi qr squared. Let us substitute. What is qs in terms of r? What is qs in terms of r?
3R.
3r. That is what we have just proven, minus pi. Qr in terms of r is just the small r. Yep. And then we get 3, we get pi 9 times r squared minus pi r squared. And that will become 9 pi r squared minus pi r squared. When we press our calculators, we should get 8 pi r squared. If I'm wrong, please forgive me. Are there any questions, or is there anyone that understands what we did? Any question, or is there anyone that understood?
Yeah, we understood it, sir.
Okay, very well. We calculated the area here. We determined the area of the flower garden. We established that the flower garden is the one that is within those two circles. So if we want the area of something that is within, that means we have to calculate the area of the bigger circle and then subtract the area of the small circle to get the remaining part. So area of a bigger circle minus area of the small circle. Generally, area of a circle is pi r squared, generally. So we say there is pi for the area of a bigger circle, and then the radius for the bigger circle is qs squared minus pi multiplied by the radius of the small circle, and the radius of the small circle is there, qr. And then we square that. Pi qs is 3r, qr is just small letter r. And then from there, it's simplification. 3 to the power 2, 9, r to the power 2, and then you drop that one. It's just simplification from there. Let us move then to another question, 7.3. In 7.3, we are required to show something. And in most cases, in those questions whereby you have to show something, there are hints in the thing that you want to show. There are tips that we have to use this, we have to use that. We want to show that RS. So let us start from there. We want to show RS. Where is RS? We see that RS is in that triangle that is in the horizontal plane, which is triangle RQS, triangle RQS. But also R is in that triangle, triangle SP, triangle RPS, triangle RPS. RS also exists there. So we have a decision to make. Which triangle do we use, RQS or triangle RPS? You answer that in that question using the thing that you want to prove. So which triangle do you think we should use between triangle RQS and triangle RPS? Which triangle should we use and why?
RQS, because it has the 2x.
Yep, that is how it goes. you will observe the thing that you want to prove. The thing that you want to prove has R and it has 2x and a bunch of other things. But the most important things are R and 2x. Well, X at least is there. So we go to these two options that we have is the triangle RPS. That triangle does not have any information there. There is no R in that triangle. There is no 2x in that triangle, which makes it not a viable option for us. And that leaves only triangle RQS, triangle RQS. So if that is the case, we have established the triangle that we have to use. Now we have to start to establish the rule that we have to use. Remember, this is a non-right-angled triangle. So we have an option of sine rule, cosine rule, area rule. That question as well, you answer by analyzing the thing that you want to prove. Can you see that there is a square root there? So if there is a square root, then which triangle do you think we might have to, which rule, I mean, if there is a square root, which rule do you think we might have to try here?
Cos rule.
Pythagoras theorem.
Pythagoras, remember you use Pythagoras theorem only in a right-angled triangle.
The cos rule.
Cos.
We will use a cosine rule. We will not use a Pythagorean theorem because triangle RQS is not a right-angled triangle.
Oh, okay.
So that means we have to use some other rule that is applicable in non-right-angled triangle. So those rules are sine, cosine, and area rule. Then we choose out of those three, sine, cosine rule, and area rule, blah, blah, blah. We choose out of these three, the one that will somehow give us a square root, 5%.
Turn on power saving mode.
Sorry?
Why don't you turn on power saving mode?
I actually disturbed the lesson. So let us proceed. I will find another way. Let us proceed. We say that we have to choose the one that will give us a square root. So out of those three, sine rule, cosine rule, and area rule, the one that will give us a square root is cosine. Hence, we are going to use cosine, and we are going to use the triangle that is containing a lot of what we want to prove, which is R and X. So the way we use this rule, this is 7.3, not 7.2. We say that we want to express R as, which means we want to express that RS. So let us begin with that RS and say RS squared is equal to, it should be equal to what?
QS squared plus QR squared.
QS squared plus QR squared, that is absolutely correct, times QS times QR, and a cosine of which angle?
Angle Q.
A cosine of angle RQS, which is angle Q in your case. That angle there, which is given to be 2x. And then let us substitute. rs squared. Remember, qs, we have proven it to be 3r. So we substitute there 3r. What is qr?
It's R.
Yep, that is r minus 2, 3r, r, and the cosine of the angle RQS is 2x. 2x over there. So now if you can look at what we want to prove and what we have, we are a little bit happy because there is cos 2x and there is cos 2x over there. There is r somewhere and we have a bunch of r over there. So that means we have a lot of cleaning to do, but that shouldn't be a problem. That is basically now algebra, not trigonometry. So that is 9r squared plus r squared, 2 times 3, that is 6, r times r squared, cos 2x. This is not a v, it's r. And then we proceed, rs squared. We collect like terms. It should be 10 r squared minus 6 r squared cos 2x. Is there anyone that is lost so far with regards to the way we do algebra? So far, so good. So far, so good, folks.
Yes, sir.
Okay, thank you very much. And now if you look at what we have here and what we want to prove, we are happier because we do have a 10 and they do have a 10. We do have a 6 and they do have a 6. We do have a cos 2x, they do have a cos 2x. So the thing that they do not have is r in that expression. So that means, that suggests now we might want to take r squared there as a common factor because they do not have r in the middle, they have it outside. So we say rs squared is equal to, take r as a common factor, 10 minus 6 cos 2x. And now we are even more happier if there is such a thing, because r now is there on its own. 10 minus 6 cos x is there on its own. What do you think we should do now? What do you think we should do?
Square root.
Yep, take the square root. R squared, 10 minus 6 cos 2x. The square root will be r. Remember, you can't take the square root of this one, so it will remain as it is. There. So are you guys happier with what we have over here? Because it's exactly what we, sure.
The second last step. So the r squared is inside the square root, and how do you just choose to take it out like that?
Oh, okay, that's a very good question. Let me take you to basics. When we have a square root of a times b, I think you can say in this case that our a squared represents that r squared, right?
Yeah.
And our b represents that long expression which has 10 and cos x. So that will be equal to the square root of a squared times the square root of b. So what is the square root of a squared?
A.
it will be equal to A, which means the square root of R squared over here is equal to R. And then you multiply it with the square root of B. Clear? Never lose your basics, my man. Never lose your foundation. Never lose your basics. Thank God. So now we have to calculate RS. The question says if R is equal to 10 meters and X is equal to 56 degrees, calculate RS. This is too easy. If they give you that question, say dango. 3 marks. What do you think we should do?
Sub in.
Substitute, that's all. That's all we do. That is all we do. I'm not even sure that this lesson is still live on Facebook. There are a lot of technicalities that have been happening. Let's come.
RS is equal to 25.78 centimeters. No, meters.
Cos 26 degrees. What do you get? What is your answer? I didn't hear it.
25.78 meters.
Yep. That is all from trigonometry. It sums it up. I think I've done the most interesting questions whereby you are given a 2-dimensional or 3-dimensional problem. You determine, you prove something, you determine something with regards to something, which is you in terms of something, you show something, and then you give them some values, and then you calculate. With regards to trig functions, I think we have done a fair share. We have plotted a graph. We have analyzed a graph as well, which we have determined. Sorry, okay.
Where can I, what's the name of your page on Facebook?
It's not my Facebook page.
It's Wesley Guild. Sir, I have a question.
It's Wesley Guild.
Sir, I'm slightly confused. Who calls where we subbed in? Did we sub in 56 or 26?
Oh, 26.
Okay. All right, I'm just making sure.
No, my bad. My bad. It's actually 56. The Facebook page, it's Wesley Guild 20, no, not 2020. Wesley Guild RSA. No, not RSA, SA.
And on YouTube?
Sir?
Wesley Guild, same word. Hello?
My other question is, classifaka lo cos 2 on the calculator, do I say cos 2 and then sub in the 56?
No, you say cos, ne? And then it will open bracket.
Yebo.
And then you say 2 times 56.
All right.
And then you close brackets.
All right.
When you calculate, it will appear as cos 2 times 56 degrees. It will appear as that.
My calculator is broken again. Okay, thanks, sir.
So I think we have done a fair share in trigonometry. At least you are going to go into that exam with some little bit idea of what to expect and how to maneuver your way around those questions.
Sir.
Are there any questions in trigonometry?
Sir.
Sure.
I've got a problem. When I substitute these things of cos 2 times 56, I don't get RSS 25.78.
Okay,
And
what do you
I'm
get?
also getting 34.
34.99.
Yeah, sorry guys, it's my bad.
Yeah. Yo.
34.
Like my calculator's broken again.
So you're getting 34.
My bad. I didn't see that it was a
34,
double
what?
angle.
Let's say it's 35 because it's 34.996.
Yes.
34.35.
It's 35.
Yo.
Yeah, you were stressing, eh?
Yeah, Lord.
So I thought my calculator's broken.
No.
And buy a new one.
It's not a calculator error this time around. It's a human error. Are there any questions with regards to trigonometry before we dive deep into analytical geometry?
So what if your phone dies?
What if my phone dies? It can never die this time around. I've got it covered.
So are we fine?
Yeah, we are fine. We're good to go.
Oh, shucks.
I've got it covered with regards to charging. There's no electricity yet, but I found a way.
Aye.
Another question before we dive deep into analytical geometry. Silence is equal to, well, not always the case, not equal to happy.
Let us proceed, sir.
Sure. We are at question 3 now, which is analytical geometry. I've taken this question as well from previous question papers. I think in total it has 19 marks.
Sorry,
in
sir.
total. Sure.
My screen is black, like I can't see your screen now.
Is there anyone that is facing the same problem?
No.
Double tap on your screen.
Nothing's really happening. I don't know why.
That sounds
Nothing
like a
even now.
problem.
Like I cannot see anything.
Sure. But others can see them. So that
Yeah.
means I'm not the one that is having a technical error. Still nothing. Hello?
Still nothing, sir.
I would recommend that you leave the meeting and enter again.
Okay, sir.
I might have to go and admit you, but yeah, we are already here. Leave and come back. I will go and check in a minute. Question 3, folks. In the diagram, we are given A. Also, this is one of analytical geometry is one of the things that rely mostly on your perspective of a statement, on how you view what is given. You have to analyze those things thoroughly and proper to a point whereby you understand it and you're comfortable with the problem. So we're given that A, B, C, and D are vertices of that rectangle, which is A, B, C, D. A, B, C, D. Those points are points of are vertices of a rectangle. Before we even proceed, it's important that we understand the properties of a rectangle, especially relative to analytical geometry. Before we even go to another statement, they said that we have a rectangle here. What do they mean by that? So I will tell you the first thing. The opposite sides of a rectangle are equal and they are parallel, always. So that is AD is equal to BC, and they are parallel at the same time. So the length or the distance of AD is equal to the distance of BC because these two sides are equal. Another thing, the gradient of AD is equal to the gradient of BC, because these two sides are parallel. So that is what we know about a rectangle. They are the pair of opposite sides are equal and parallel. The same is true for DC and AB. If we calculate the distance of AB, then we know the distance of DC. Those two sides are equal. If we calculate the length of AB, that is the length of DC. Similarly, if we calculate the length, the gradient, the gradient of AB, that will also be the gradient of DC, because those two lines are parallel. So these are the properties that you must know when it comes to a rectangle. Another thing, we have two lines, line AC and line DP. Those two lines have a name in mathematics. Who wants to take a guess about the name of those two lines?
Diagonals.
They are diagonals. Yep, they are diagonals. And there's an interesting thing about these two diagonals. The first diagonal is equal to the second diagonal. AC is equal to DB. Those are the properties of diagonals of rectangles. AC is equal to DB. So if we want the length of DB, we can calculate the length of AC, because those two diagonals are equal. The length of DB, if we want it, we can determine that of AC. So if AC is 4 units, that means DB as well is 4 units, because those two lines are equal. Another thing, as we are still talking about diagonals, this is the analysis of the given information. Once they said a rectangle, everything that I've just said should come active at the back of your mind. Another thing that the last one that I'm going to say, M there is the midpoint of AC, also the midpoint of DB. I will say it again. M there, where the diagonals intersect in that point. M there is the midpoint of AC, which is also the midpoint of DB. That means DM is equal to MB. Also AM is equal to MC, because M is the midpoint of that diagonal. So if we want to calculate those coordinates of M, we should use somehow a midpoint formula. This is the information that we have derived from only one line, which said that this is a rectangle. We got that information, all of it, from that statement. Let us proceed. We are given that the equation of AD, which is that line AD, is y equal to 2x plus 16, that line AD. Before we even go after that one, before we go to the next line, remember the equation of a line is equal to y equal to mx plus c. So what is the gradient of line AD? Who wants to take a guess? What is the gradient of line AD?
2.
Hello? What is the gradient of line AD?
2.
2.
2. That 2 over there. So if the gradient of line AD is 2, what is the gradient of line BC?
It's also 2 because they are parallel.
Yep, it is also 2 because they are parallel. And you conclude this using the fact that this is a rectangle, the analysis that we have just done. So let us proceed with the question, with the statement. Line AB, where is line AB? There. Cuts the y-axis at G. Okay, that's fine. There's nothing very interesting about that. Well, maybe there is. If a G is the x-intercept, when you calculate if G is the y-intercept, when you calculate the coordinates, which one are you going to put it as x, as 0, I mean?
X.
X will be 0 there. Then you calculate your y. So if you have an equation of a straight line, in the place of x, you will put 0. That is what they mean about the y-intercept. Let's move. And then they say the x-intercept, you know, when they talk about x-intercept, y is 0. The x-intercept of line BC, where is BC? There is BC. Has those coordinates f, x and p, and y and 0. So that is the given information, nothing much. And then the angle of inclination of BC with the positive x-axis is alpha. So that angle of inclination there is alpha. I think let us analyze that angle of inclination. There is some relationship between the angle of inclination alpha and the gradient of that line BC. There is some relationship between the two. The gradient of line BC and that angle of inclination. And that relationship is that the gradient of line BC is equal to the tangent of that angle of inclination alpha. Have you seen something like this before? Normally they use theta.
Yeah.
Yep. So if they say calculate that angle alpha, you will just substitute the gradient, the gradient, which is 2. And then you do your thing. Turn, shift, turn, and stuff like that. Like determining a reference angle. Easy. So let us finish off with this statement. They say that the diagonals of the rectangle intersect at M. The diagonals of the rectangle intersect at M. I think we have analyzed that. That M there is the midpoint. Are there any questions with regards to everything that I've just said? By doing this analysis, I'm not trying to waste time, but I'm giving you the thinking process behind solving these questions. It is the thinking process that I would recommend that you use in the exam hall. You analyze the statement correctly and properly, and then you end up answering questions that, you know, are not even asked. Okay.
Is the base of the rectangle and the height of the rectangle perpendicular to each other?
The what?
Are they perpendicular to each other? The base of a rectangle and the height?
Yeah, they are.
A length. Okay, sir.
The corners of the rectangle are equal to 90 degrees, those corners. So that is what he is saying basically, which is a very good analysis. Thank you very much. The corners of those of that rectangle are equal to 90 degrees. So let us move and answer the questions. The first question says, calculate the coordinates of M. I think let me let you do this one, and then after we have done it, we will discuss it here. The coordinates of M. Please do calculate it on your side and let me know what you get. The coordinates of M.
The X value I got.
Negative 1, 1/2, and 5/2.
Okay, that's good. Absolutely good. We said M is x1 plus x2 divided by y1 plus y2. We use the midpoint formula because M is at the intersection of two diagonals, which is the midpoint.
Sir,
So that, sorry?
before we sub in, do we first have to write down this formula?
Yes.
Okay.
And then you say, let us say the first, that point A, we will say is 1, and then that point C is 2. So we see that x1 is -7, x2 is +6. We divide by 2. y1 is +2, y2 is +3. And then we get that M is -½ and 5/2. Nice, nice. This follows directly from the analysis that we have done. Let us go to 3.2, whereby they want us to write it down, the gradient of BC in terms of P. The gradient of BC in terms of P. The gradient of BC in terms of P. So they talk about BC. Let us check where is BC. There is BC. So they want us to determine the gradient of BC in terms of that P. So we will use a gradient formula for that. So the gradient of BC is equal to y2 minus y1 divided by x2 minus x1. So we do not have this point B, but we do have that point C. But we can also use that point F in the place of B, because these points are on the same straight line. Point B, point F, and point C. They are on the same straight line. So if we do not have B to calculate the gradient, we can also use that F, because that F is on the same straight line as B and C. They are what we call collinear points in analytical geometry. So the gradient of BC is equal to, we will say F is 1 and then C is 2. So y2 will be 3, y1 will be 0. What will be x2?
6.
6 minus what will be x1?
P.
P. So the expression of a BC in terms of P will be basically 3/6 minus P. Are we happy with that answer and the approach?
Yes.
Okay. Now let us move to the question that I believe follows exactly after 3.2, which is 3.3. They say there, now that we have expressed that gradient of BC in terms of P, can you then calculate the value of P? Who wants to take a guess? How do we calculate the value of P?
Substitute the gradient which we got by dA. 2 is equal to the formula.
Yep, that is the case. There are two unknowns from that diagram, from that formula. There is MBC, which is the gradient of BC, and there is P. So we want to calculate P, so that means we have to substitute the value of the gradient of BC. So let us analyze our diagram. There is the line BC. We said that line BC is parallel to that line AD, and the gradient of AD is 2. That simply means the gradient of BC as well is 2. That is, this follows exactly from the analysis we did when we were analyzing the statement. Hence, I advise the thing of analyzing the statement properly. You will find it very, well, not easy, but you will find it a little bit better to analyze to do these questions once you get to understand the statement. And then we cross multiply. 2, 6 minus P is equal to 3. 12 minus 2P minus 2P. 3 minus 12. Is that 9? Minus 9, right?
Yes.
And then we divide by that -2, divide that by -2, you get a value of P equal to 9/2. Are there any questions? Are you okay with the procedure that we have taken?
Yes.
Okay. Now they say calculate the length of PT. They say calculate the length of PT. Who wants to take a guess?
We don't have the coordinates for D and B, all right? But when we were doing the analysis, we also got that AC is equal to AD because the diagonals are equal. So we can just use those, we can use the distance formula, and then we can just insert A and C's coordinates, and then we can find the thing.
Danko, I like the fact that you are saying when we did the analysis, we found out that, I like that statement. When he said, when we did the analysis, we found out that BD is also equal to AC. So if you calculate the length of BD and you do not have the coordinates of B and D, then you should just calculate the length of AC. So you do have the coordinates of A, you do have the coordinates of C. Can you calculate on your side and then let me know what do you get? The more you do it, the better it becomes.
Should I answer or should I give others chance to calculate first?
Just answer, I think, yeah.
I got 3.4 units.
You got 3.4 units.
Yes.
And then others will come and verify whether their answer is similar to yours. And then after that, we verify if your answers are correct. Are you winning, folks?
I got 13,03.
13, not 3.
13. That's why I double checked.
13.
13,03.
It's 04 because you need to round it up.
04. Okay, whoa, sorry.
Very interesting.
Oh, yeah.
It can also be written as square root 170.
Have you seen your mistake or?
Not yet. Let me check. Let me double check.
Not yet. Okay, let us do it here then. Remember, we have to say one of those two points is 1 and one of them is 2. So we said point A is 1, point C is 2.
Oh,
that means.
Sorry, I did see my mistake. I used F instead of A. I now see my mistake.
Oh, okay. So you calculated the distance of FC.
Yes.
Makes sense. So X2, no problem. X2 is 3. 3. Very interesting. X2 is 6, not 3. And then minus a minus of 7, which will be a plus 7. And then Y2 is 3 minus a 2. You should press that on your calculator and get 13,04 units. Easy. So that is the distance of AC and also the distance of DB. So now I think you all get the point that if we calculate the length of MD, the length of MB, that would be half the length of DB, because this line DB is divided equally by that midpoint M. Hence they say it is the midpoint. Similarly, AM is half of the entire line AC, because that M divides AC equally. Hence they call it the midpoint. Is everything clear so far?
Yes, sir.
All right. Let us proceed to 3.5, which is not here. There is 3.5. Oh, yeah. There is 3.5. They want us to calculate the size of alpha. I think this is something that we have entertained when we were doing the analysis. We have entertained it and we left it in the middle. Can you calculate on your side and show us how you got there? The size of alpha. 2 marks.
63,43.
All right. So how did you get there? I want the thinking process, most importantly.
I use the inverse of tan and 2 to find my answer.
Okay, can you say it again? Because I didn't hear you. You were cutting.
Okay, I'll just take over. It's fine.
Oh yeah, take over, sir. Take over, sir.
Okay.
I said,
Are you the inverse of tan?
Thank you. Thank you.
sir.
Can you take over, sir? Sure.
So we found out that the gradient for BC was 2.
Sure.
So we just said tan alpha is equal to 2. And then we said arctan 2 is equal to 63.43 degrees.
Equal to what?
63.43 degrees.
Yep.
Thank you.
Danko. If you look at this, it follows exactly from the analysis that we did. So I think everything, well, I think you are finding these questions a little bit easier because you have a very strong analysis of what is given to you. That's why I recommend that you analyze those statements there in the exam room. Make sure that you analyze them properly. So let us move. A very interesting one, the size of OGB. Very interesting one. The size of OGB. Remember, alpha is 63.43. I think we might have to use that. The size of OGB. Where is OGB? There is O, there is G, there is B. So we are calculating the size of that OGB. The size of that OGB. So we want to find out how do we get there. So there is one thing that I would suggest. It will be a little bit long though. I think my method will be a little bit long, and this is only 3 marks. There might be another shorter way, but I'm seeing the one that is a little bit longer. Okay.
So what if we find the gradient of AB?
Yeah, that is the idea that I have, but that is what I'm saying. It might be a little bit longer for 3 marks, but I think let us use it. Let us use it because that is what I see as well. So we want that angle OGB. We see that that angle OGB needs us to have that angle first. That angle that I don't even know. And for us to have that angle, we need to have that upper angle first. And for us to know that that upper angle, we need to know the gradient of AB first. Hence, I'm saying it's a little bit long because we want this angle. That means it will need us to have that angle. This angle will need us to have that angle, and that angle will need us to have a gradient first. So we have to begin at a gradient, go to that angle of inclination, go to that angle in that smaller triangle, and then when we have that angle, we determine that OGB. Because OGB is equal to this angle plus that 90 degrees. At the point of intersection between x-axis and y-axis, there is an intersection there, and it is equal to 90 degrees, the angle there. So that OGB is equal to the angle, that angle at the bottom plus 90 degrees, because OGB is the exterior angle of this smaller triangle. OGB is the exterior angle of this smaller triangle. Therefore, it will be the sum of the two opposite interior angles, that angle plus that 90. But we do not have this angle. And in order to find it, we need to have that angle first, that angle at the top. And for us to determine that angle at the top, which is the angle of inclination of this line, we must determine that gradient first, that gradient of that line AB. So that is why we have to start at that gradient. Hence, the brother suggested that we use the gradient. Hence, I'm saying it's a little bit long method for 3 marks, but it's what I have at the moment. Well, it's what we have. Maybe we might not have to even determine the gradient. Very interesting. Sure.
Did Prof not mention that BC is perpendicular to AB or something?
Yes, he did.
And then can't we to find the gradient of AB, say gradient of MAB plus 2 is equal to -1. So we can find the gradient of MAB.
Did you say plus 2?
I mean times, sorry, my bad.
The gradient of AB
multiplied
times the gradient of BC,
yeah,
is equal to a -1.
Yeah.
And then the gradient of AB multiplied by, that gradient is 2, right?
Yeah.
So the gradient of AB
negative
will be equal to a negative. Where is this 2 coming from?
From the gradient of BC.
I'm talking about the denominator. Did we divide?
Yes.
You put it there now,
okay.
and then on your next step.
Sorry?
Keep going, sir.
We divide, yeah. Okay, I see 2 is flying here. -1/2. So that is how we get the gradient of AB. And then we determine that angle as the angle of inclination. How do we calculate it? We will call it theta.
Okay, tan theta.
Okay.
Is equal to -1/2.
Yeah, how do we get there? Very interesting. I want to see how you are going to handle that negative.
And then can you not just say arctan is equal to, you sub in -1/2?
No, we don't substitute a -1/2.
1/2, and then you say 180 minus.
We do not substitute a -1/2.
Okay.
We say this negative will be accommodated by 180 degrees minus. And then we say tan arc of half. In that arctan, we substitute only the half. We don't bring that negative in that substitution. That negative is accommodated by that 180 degrees minus. Remember, tan is negative in the second quadrant, right? Are you familiar with that?
Yes, yes.
Yeah. And in the second quadrant, we do have 180 degrees minus as a reduction formula. Hence, there is that 180 degrees minus there. Do you get me?
Yes.
Yeah. That 180 degrees minus is from the second quadrant. Why we choose second quadrant? Because tan is negative there. So this is where we have to get an angle that is greater than 90 degrees. Press a calculate and see.
153.
Yeah.
153.
153,
43.
43. Okay. Can you determine theta using the method that you were talking about, where you substitute the negative and see the difference?
I can see I'm going to get a negative answer. Then it's gonna be
What
wrong.
is that negative answer?
I did not check yet. Let me check.
I want that value and the sign as well.
Negative 26.5.
Negative 26. So if you can see that 26 is an angle between 0 and 90. And if you check your angle here, the angle of inclination, looks like an angle that should be greater than 90 degrees. It shouldn't be equal to 26 because 26 is less than. Hence, this method is preferable when you have that negative over there. You do not include it in your calculations. You accommodate it by saying 180 degrees minus, or it's always that 180 degrees minus, always. So now, what we see is that we do have that angle, the one that I've highlighted it with a red what. Let me just write theta there. That is our theta. Now we have to calculate which angle. That smallanyana angle there. How can we calculate it?
180 minus theta.
Yep, 180 degrees minus theta, that more smallanyana angle there. I will call it beta. Are we okay with that? So we know that these are angles on a straight line, theta and beta. So theta plus beta should be equal to 180 degrees, angles on a straight line. So beta plus theta should be equal to 180. And then we say beta is equal to 180 degrees minus 153 plus 43 degrees. I think you should be getting that 26 now.
Yes,
What are you getting?
26,565.
7, right?
Yeah.
Yes.
Yep. We are happy with that because that angle looks very small. It should be between 0 and 9, at least, and 90. And then we go to our main question, where we calculate the value of OGB Remember we said OGB, that angle there is the exterior angle of that smallanyana triangle. So that exterior angle should be equal to the sum of the two opposite interior angles. So OGB is equal to beta plus 90 degrees. OGB is equal to beta plus 90 degrees. So beta is 26,57 degrees plus 90 degrees, which is equal to what?
11657.
Yeah. Yeah, that was a little bit long for 3 marks. Did you guys understand it though?
Not really.
Yeah?
It's too much.
It's too much.
Sir? Sir?
Sure.
Why didn't you use the gradient of
Yeah, your internet connection is cutting you.
Is there no quicker way?
Type the problem on the thing.
Sir,
Hello?
Mina, I used
calculate the angle of G because those are collinear points. I say why did it to click?
We can't hear you, brother, because your internet connection is cutting your voice. So I really didn't hear your question.
Okay, so Mina, when I substitute, I said 180 minus 63.43, that the alpha, I don't know, is alpha, size of alpha. I substitute it to, I minus it to 180. I get 116.57.
You said 63,
43.
The one we calculated for alpha, right?
Yes.
You substitute, you subtracted from who?
180.
Why?
Is the problem.
Yeah, that is the problem. What are you determining? Because in maths, every move that you make, you should be able to justify it.
Okay.
Now you have got a value that you don't even know whether it's for which angle. Well, basically, when you calculate, when you say 180 degrees minus 63,43, that basically means you're calculating that angle, because those are angles on a straight line. So where to from there?
It makes sense. There is no shortcut in mathematics.
As much as you have to justify your steps in maths, even if you don't have to write the reasons, but at the back of your mind, you should know that, okay, I'm doing this because of this reason. I'm doing that because of that reason. I think let us move to 3.7. This was 3.6. There is the brother that wanted to ask a question. Are you able to type it at the chat box, and then we will just ask someone that has a good internet connection to read that question? Can you type, brother? Guys, can you be on the lookout?
Okay, sir, I'm trying to type.
Yeah, please type, and then we just move for now to another question until we are done. So let us go and do 3.7. Who has a good connection that can read for us? Can someone read for us? 3.7.
3.7. Determine the equation of the circle passing through points D, B, and C in the form of x minus a squared plus y minus b squared is equal to r squared.
Very well, thank you very much. Now we are required to determine the equation of a circle. And if you look at what we have there, there is no circle. So you have to sort of awake your imaginations. We are told that the circle is passing through point D, point B, and point C. There is D, there is point B, there is C. So there is a circle around there. There is a circle around there, a circle around there. We do not see it because it's not drawn, but we can visualize it. We can imagine it. That is the word that I wanted. We can imagine it. A circle through point B, C, and D. So the first thing that we have to identify when we deal with an equation of a circle is that we must have a center. And we must have a radius. So our center is A, B. So from the circle that we have there, we need to make some analysis and conclude where is the center. Sure.
Here's the question.
Sure.
Why didn't we use the gradient of AB to calculate OGB? Because OGB looks like an angle of inclination.
Why is it that we did not use what?
The gradient of AB to calculate OGB.
We did use the gradient of AB.
Okay. Hope you got your question answered, Lazarus.
Did he say AB or OB?
AB.
No, we did use it. We used the negative half, and that is the gradient of AB. Okay, can you read the question again? Maybe not sure. Sure.
Could you please look at OGP as an angle?
Please type your question because you're cutting as well. Is there anyone with a clear network? Can you read that question again, the one that was just sent?
It says, why didn't we use the gradient of AB to calculate OGB? Because OGB looks like an angle of inclination.
Oh, I get now. I get his question. No, OGB is not the angle of inclination. The angle of inclination has to be the angle between the line and the x-axis. The angle between the line and x-axis on the right-hand side of that line. So alpha is the angle of inclination. But OGB is the angle between the y-axis and the line, not x-axis. So OGB is not the angle of inclination because of that reason. Hence, we did not use that gradient of AB to calculate OGB directly. So I hope that is answered. Yeah. So as I was saying, we need two things. We need the center. We also need the radius. So from that diagram and the given information, we should analyze to a point that we can see what is the center. A center is the point in the middle of the diameter. A center is the line that divides the diameter equally. No, a center is not a line. No, please. A center is a point. A center is a point that divides a diameter equally. A point is a point. A center is a point that divides the diameter equally. That means we should have a diameter there. This circle is passing through D, B, and C. In that circle, we must have a diameter. In Euclidean geometry, we have learned that the diameter subtends an angle of what value at the circumference? Who wants to answer that question? A diameter is a line that subtends an angle of what value at the circumference of the circle? Wants to take a guess?
90 degrees.
And 90 degrees. So between a point D, point B, and point C, which one has 90 degrees according to the analysis that we have done?
C. All of them.
No, not all of them.
C.
C. C is 90 degrees. Kalogu, my brother, we are focusing on the circle that it is here. So C is equal to 90 degrees, that angle over there. So if C is equal to 90 degrees, then that makes DB to be what line?
A diameter.
To be a diameter. If DB is a diameter, then which one is the center?
M.
Excellent. Absolutely correct. What are the coordinates of M?
-1/2 and negative.
And 5
if I still remember well, they were like that. Radius can be defined as the diameter divided by 2, right? What is the diameter? What is the length of the diameter? I think we have determined it on our previous answers. What is the length of the diameter?
It was 170. Square root of 170, which is 30.
Square root of 170, which is what?
13 point something.
No, don't just write it in a set form.
Yeah.
So is it 170?
Yeah.
Divided by 2. It seems like we have everything we need. We have the center and we have the radius. So the key here was to identifying the diameter. Then from there, everything else flows. X minus minus of the formula and times that minus of the x value at the turning point at the center will give us a positive. Y minus 5 over 2 equal to R, which is the root of 170, the root of 170 divided by 2. What do you get? What do you get for R?
For 42,5.
No, don't write it as a comma.
85 over 2.
85 over 2. I would advise that when you deal with analytical geometry, you leave your answers in a set form or in a ratio form or a fraction form. Unless you are calculating distances whereby you would be required to identify if two sides of a triangle are equal and stuff like that. But I would recommend in analytical geometry, you leave your answers in a set form or in a fraction unless it's necessary to put it in a decimal form. So we have done question 3.7 and we go to 3.8, which I think should be a little bit hectic than the one that we have just done because it is the last question. They say that if AD, where is AD? There is AD. Let me clean my diagram. If AD is shifted so that ABCD becomes a square, very interesting. If AD is shifted so that ABCD becomes a square. So in order for that to become a square, that means we should shift AD in that direction. We should shift AD in that direction, which means AD should be somewhere, somehow. Because a square is a figure where all the sides are equal. All the sides are equal. So for all the sides to be equal, AD has to come a little bit closer to BC. AD has to come a little bit closer to BC. Okay, we get the idea. And then they tell us that if AD is shifted so that ABCD becomes a square, okay, will BC be a tangent to the circle passing through A, M, and B, where M is now the intersection of the diagonals of the square ABCD. Motivate your answer. Very interesting. Really interesting. Who wants to take a guess? Who wants to take a guess?
You could just say yes. So we can say yes that it's a tangent because it touches B because the circle passes through points A, M, and B is the start of BC, right? And maybe touches that place and it becomes a tangent.
I didn't hear you at all.
So I just improvised that. I don't think it's right. Sorry.
No, say it again. Maybe you are on the right track.
I said that so the circle is passing through A, M, and B, right?
Okay.
And the tangent will be BC. So if it's passing A, M, and B, it touches B. So it's a tangent.
If the circle is passing through A, M, and B, right?
Yeah.
And then that BC will be touching the circle at B.
Yeah.
Remember that A will no longer be there at that time, so it will be a little bit around there because we are going to pull that, we're going to shift that AD towards BC so that this figure will become a square. So your A now will be a little bit somewhere. So this circle will be around there. So will BC be a tangent? So your answer is yes, BC will be a tangent. And you are justifying, you say, because it touches the circle at B. You said, right?
Yes, sir.
Okay. Well, I'm not sure about the answer, whether it's correct or it's wrong, but your justification is not sufficient to convince me that it will be a tangent. Because you say that it touches the circle at B. And that's not enough to convince me to say, no, it will be a tangent. It might not be. Maybe there will be another point where it touches the circle. We do not know. So I need another proper reason that will convince me. Anyone? Will it be a tangent?
I'm guessing no.
You're guessing. Okay, let's go with your guess. How do you justify your guess?
I don't even have a proper justification, but if
Now
A
come with the one that you think is not proper. Maybe it's proper.
if A is shifted, right, and moved closer to the y-axis, right? And then it says there that our points of the circle have to run through A and M, right?
A, let's say M is around there.
There.
A, M, and B, absolutely.
And looking at that, doesn't look like B could be the tangent.
Doesn't look like, yeah. I get your justification.
It looks like it's gonna, cut. Because if B is the tangent, isn't it gonna be an oval rather than a circle?
Yeah, it will be a little bit squashed.
Yeah, it's just a guess.
No, we're not sure whether the answer that it will not be a tangent is the correct answer. We are not sure yet. So let us work through it. Very interesting. There is M, let's say A is around there, which I'm not even sure whether it's around there. And then it crosses over there. The angle that will be there will be 90. And the angle that will be there will be a 90 as well. The intersection. Oh, okay. A cannot be here because that means Yeah, there will be no diagonals anymore. Okay. Oh, that's nice. Oh, really nice. Okay, this lies in the properties of what we call the square. The properties of what we call a square. Let me draw a square for you. Yeah, now we are getting there now. Let's say this is a square. Let's say that is a square. So basically, that point will be A. That point will be M. That point will be it will not be M. It will be D. That point will be B, and that point will be C. So if we drop that AD and we shift it towards BC, that AD will get closer to that BC. So it will be around there. And then that is our 18. So our diagonals will be like that now. So there is M. We are told that this line passes through that point A, M, and B. There is something that I want to mention here. That angle A, B, C is equal to a 90 degrees. I think this is something that we understood earlier on. It's not even a shock anymore. That angle will be 90 degrees. I think we can agree on that. Another thing that I want to introduce now, this is something that we did not say before because it was not there. You see, when we were talking about the diagonals of the rectangles, the angle where the diagonals met was not equal to 90 degrees. The angles where the diagonals met, that angle was not equal to 90 degrees. But that angle in a setup of a square, that angle is equal to 90 degrees. So those are the properties of a square. Their diagonals meet at 90 degrees. So if there is a circle through AMB, if there is a circle there, then what is AB? What is the name that you can give to AB?
Diameter.
If it subtends. Exactly. AB will subtend 90 degrees if AMB, there will be a circle there. If there will be a circle there, then AB will be subtending 90 degrees at the circumference of the circle, and that will make AD a diameter. That will make that, no, not AD, AB, a diameter. And now, if you check that, okay, this is a diameter, and then that BC, what is the angle between BC and the diameter? What is the angle? 90 degrees. The angle between AB and that BC is 90 degrees. The angle between the diameter AB and that line BC, the angle is 90 degrees. And that is possible only if that BC is a tangent. Because the angle between the tangent and the radius, or the angle between a tangent and the diameter, has to be equal to 90 degrees. So if that angle there is 90 between the diameter and that straight line BC, that means that straight line BC is a tangent. So that is how we get there. Nice. So that's a tangent. Yeah, it's a tangent.
How would we write the answer to this now?
Very interesting. How would I write the answer for this one? Let me see. Did you understand my analysis though, before we get to the writing process of the answer?
Very good one.
Yeah, did you get the analysis?
Yes.
Okay, well, that's good. What about others? Did you get the analysis?
It's very complex.
Yeah, it is. It is. It needs to understand properties of you will write your answer in this way. You will say yes, and then you will say A M B. That angle A M B will be equal to 90 degrees. So those are the properties of diagonals of a square. Diagonals of a square. That will be 90 degrees. And then that makes line AB. You can just say, therefore, AB is a diameter. Or will be a diameter. And then you say AB is perpendicular to BC because you have a 90 degrees there. So once these are perpendicular, then that means that tan should be equal to a tangent, which means it justifies your yes. It's a little bit complicated, but we are about to finish now. Only one question left, only one in analytical geometry. Then we wrap up. Only one question.
Oh.
Yeah?
Yeah, this looks hard.
It looks hard.
No, it's always hard.
Which one is hard?
Question 4.
Question 4. Hopefully you will come out of the lesson with a new perspective.
Yes, please.
Yeah, hopefully. Let us say, let us analyze the statement. In the diagram M, this is the last question. This is the last question. In the diagram M, there is M, which is, sorry about that. In the diagram, M is the center of the circle passing through T, S, and R, or through T, R, and S. So that is the circle, that is the center. So if M is the center and TR is the diameter, then what is that angle S?
90 degrees.
90 degrees. So
Angle in a
angle is in a
semicircle.
semicircle. Yeah. That is why that angle is 90 degrees. And then RT is there, which is the diameter of the circle. That's fine. And then K is given as that point on the fourth quadrant. I think it's important why they mention fourth quadrant. They barely talk about quadrants in analytical geometry. So if they say fourth quadrant, maybe they want us to understand the signs of those values A and B. What can you expect to be the sign of A? Positive, because it is on the positive side of x-axis. What can you expect to be the sign of B?
Negative something.
Negative, because it is below the x-axis. So maybe that's why they mention fourth quadrant, which rarely happens. And then they tell us that KTL is a tangent to the circle at T. KTL is a tangent to that circle. Which conclusion can you draw about this line being a tangent? What can you say? What is that angle?
90 degrees.
Yep. Why that angle is 90 degrees?
Tan ray, positive, perpendicular something.
Yeah, tangent is perpendicular to the radius or to the diameter. That is the thing that we used to answer that question of a square. So first question, 4.1, why TSR is equal to 90 degrees? 1 mark.
Angles in a semicircle.
Yeah, angles on a semicircle. Angle on a semicircle. Not cycle. Why do I write cycle? Angles on a semicircle. Let us go to 4.2. Calculate the gradient of TS. Easy, huh? Because we do have the points M, Y2 minus Y1, X2 minus X1. So we will say point T is 1, point S is 2. So what will be Y1? What will be Y2? I mean, what will be Y2? Yeah, that will be 2. What will be Y1?
7.
Absolutely correct. And then we divide by 5 minus 3. What do you get?
5 over 5, negative 5 over 2.
Negative 5 over 2. Yes, I get a negative 5 over 2 as well. And then we go to 4.3. Let us determine the equation of SR. Do we have the gradient for SR?
Yes.
What is it?
So it's going to be 2 over 5.
Yeah, it is going to be, we will just find the reciprocal of 5 over 2 and change the sign. So if it is 5, because TS is perpendicular to RS. So if the gradient of TS is 2, then the gradient of RS will be negative 1 over 2, we just flip the number and change the sign. So it will be 2/5. Do we have any point in that line SR?
Yeah.
Yeah. Let us then use that point and this gradient. What is Y1?
Y1 is 2.
Y1 will be 2. What is our gradient? 2/5. Our X1 will be 5. 2/5 times X. And then we multiply to get a -2. 2/5 X. We will take out this -2 to the other side, right? And then it will become a +2. This -2 will become a +2. So a -2 plus a 2, that will give us a 0. Yeah, and then the equation of SR or RS
0.5x is correct.
Is this correct?
Yes.
It looks very strange because this would mean that it will pass through the origin, but it's not drawn to scale. Let us say it is correct. So is question 4 hard so far?
No.
No, it's not.
The hard stuff is getting there.
The most important part, my man, is proper analysis of the given information. So let us go to 4.3. Yeah, I think this is where now it gets to be warmer.
Told you.
4.1. We are given the equation of the cycle above is that form. Before we even analyze and answer, before we answer questions, let us look at those two numbers. Those two numbers are written as mixed fractions. It is advisable that we write them as whole numbers, as
improper
fractions, not improper or proper fractions, not mixed fraction. So do you know how to convert it?
Use calculator.
Yeah, just use a calculator. What is 6/2?
Is 13/2.
13/2, absolutely correct. What is 36?
145/4.
And a quarter.
145/4.
145/4. Because mixed fractions are a little bit busier than improper and proper fractions. So now we want to calculate the length of TR. The length of TR. Where is TR? There is TR.
The diameter.
Yep, the diameter. Remember that equation is the equation of this cycle, right? So if we want the diameter of the circle, maybe we can find the radius and then multiply it by 2. Do you think that is the case here?
Yeah.
Yeah. Because a radius is equal to diameter over 2. Seems like I'm doing read R. Radius is diameter over 2. That means the diameter is 2 times R.
Yes, sir.
Do we get that analogy?
Yes, sir.
Okay. So in order to determine the diameter of this radius, maybe we have to start with the radius. How do we determine the radius?
So it's in the formula.
Sorry?
Just square root 36, 36 and a quarter, which is 145 over 2.
How did you get there?
So we know that the equation of a circle is x minus a squared plus y minus b squared, which is equal to
Absolutely
r squared.
correct. So that 36 and a quarter is actually r squared, right?
Yes, sir.
So that 145 over 4 is r squared. So if we want r, we should take a square root of 145 divided by 4. What do you get?
145 over 4. I?
What do you get? 100.
Wait. 145 over 2.
Sorry, what do you get?
145 over 2.
It can't be.
6,02.
Square root 1,5. Square root 145 over 2.
Yeah, it should be square root 145
over 2.
Over 2, not 145 over 2.
Sorry, my bad.
Square root 145 over 2. You were giving us an answer that is in a decimal form. I think there was something that was giving us that answer. If you look at this question, it says calculate the length of TR.
Oh, insert form. Oh.
Yeah.
Okay.
Remember what I said earlier. Most of the time in analytical geometry, you don't necessarily have to express your answers in a decimal form unless you are told to do so, or unless it's necessary to do so. Most of the time, just leave it in a set form or in a fraction form.
Yeah.
Okay.
Hello?
Yeah.
Sure.
I think we should multiply by 2 because that's the radius and we want the length of TR.
Yeah, we are getting there.
Okay.
So TR is 2 times R, 2 times the root of 145 divided by 2 equal to the root of 145. So that is the radius. Is it difficult so far, sir?
No.
Oh,
yeah, you're making it look easier, but when you're writing the exam, you won't be there.
I won't be there. No, what I'm doing here is to give you the thinking process that I'm using to make it easier, so that you can use the same thinking process to make it easier for you. I'm hoping that you are watching and taking a few things into the bag of your tools for Monday.
Tomorrow.
Tomorrow. Oh, ooh, that's nice. Calculate the coordinates of R. Nice again. The coordinates of R. There is R, which is part of that midpoint of you. I'm giving you the answer. Part of that diameter there.
Oh, I think we can just say 3 plus 145 square root.
145.
Because like we have that, we know that T is 3 and 7, right? The X coordinates is 3. And then we know that the radius is, the diameter is square root what? No, diameter is
square root of 145.
Yeah.
Okay.
No, that was the radius. The diameter is not the... Yeah, the diameter. The diameter is 145, square root 145.
Sure.
So can't we add 3 to the diameter to get the x coordinate of r?
Okay, what about the y coordinate?
And then we can just sub in the x coordinates in the formula that we calculated.
Which formula?
The one we did in 4.3.
In 4.3 to the equation. The equation of a straight line. Oh, okay. Well, this is, I don't think this is valid. I don't think it is valid. Yeah, I don't think it is. It would be valid if, would it be? Yeah, I think it would. If we were told that this line TR is parallel to the x-axis, if we were told that was the case. Because that would mean moving from T to R, that would mean, yeah, no, I will make it more confusing. But this formula is not, this method is not valid. We have to use the method of a midpoint. Because we do have that point T, we want point R, and we do have the midpoint of TR. So it's like when you are given the 2 points T and R, and then you calculate the midpoint, but now we are not given the points of R, we are actually given the midpoint. We have to calculate the coordinates of R. What are the coordinates of the midpoint?
9.
9, yes. From the we take them from the circle.
Yeah.
Okay.
And positive, what was it? 14 over something.
13 over 2.
Yeah, 13 over 2, yeah.
Yeah, 13 over 2. So what we are going to do here is that the x value of T plus the x value of R divided by 2 should be equal to that 9. I think that is what we do when we calculate the midpoint, right? We say the x value of T plus the x value of R divided by 2 should give us that x value of M. Are you familiar with what I'm doing?
Yeah.
So that will be equal to 9. We do know the x value of T. We know it's 3 plus XR divided by 2 equal to 9. Then we solve for that XR. We cross multiply. We get XR. We get 2 times 9 to be 18. And then we minus that 3 to get 15. Do we get now how we calculated the x value of the x value of R?
Yeah.
Okay. Do you understand why it is different from your method?
Yes, sir.
Okay. So how can we calculate the value of Y?
So we
will use the same method. How do we calculate it?
We will say 13 over 2 is equal to 7 plus y2 over 2.
Let us start with the formula. Y of T plus Y of R divided by 2 is equal to 13
over 2.
Yeah. And then we say YT is equal to 7. That YT is 7. And then we say plus YR divided by 2, which is 13 over 2. We cross multiply, we should get a 7 plus YR equal to 13. when you take this 2 and at the denominator and you multiply it, you multiply with it on the right, it will be 13 over 2 multiplied by 2, which should give you a 13.
Yeah.
And then our YR will be equal to 13 minus 7. What is that?
6.
6. And
Is
then
that
the coordinates of, sorry?
There's a much quicker way to finding the Y value. We found the formula for SR, ne? So you could have just subbed in 15 into the formula.
Oh yeah. Brilliant. So it's not hard anymore. Because you get to see the ideas that, oh, actually no, man, there's a quicker way. And once you get to see those things, that means, now you're getting it. Did you understand what we have just done here? Yeah, guys, did you understand it?
Yes, sir.
Where is everyone?
Yeah, only 4 participants.
Sorry?
They are tired.
Oh, okay.
Don't worry, we've got stamina for this.
We're going to finish in a few minutes. So we have calculated the coordinates of R to be 5, 15, and 6. Let us move forward. Let us calculate sine R. How do we calculate sine R? Remember, this is 90 degrees. So how do we calculate sine of R?
Can we use trig ratios?
Yes, we can. We can use trig ratios. Did we have a distance somewhere?
Yes.
Because we will need a distance to calculate the size of
The distance of the diameter.
Yeah, they are awake now. I can hear them saying yes.
No, that's me.
You will need the distance here. And I think we somehow calculated distance of R or the distance of TR, the root of 145. So that side, I think, let me clean these coordinates. I don't think I need them anymore. So that side is root of 145. Do we have another side here? Do we have another length?
No, but I think we can calculate it.
Yeah, you can calculate it. Any other length, be it it's TR, be it is TS, or it is SR.
Let's get TS because we need TS.
Yeah, let us get TS. Now calculate it from your, okay, calculate it on your calculator and then I will write it here. Let us calculate, guys, the length of TS. The length of TS. Because we want SR here. So we want sine R,
I have root 29.
And sine R will have to be TS, which is the opposite side, over the hypotenuse, which is TR. We do have TR, which is the root of 145. That means in order to determine sine R, we must know what is the value of TS. Hence, we come here and determine the distance of TS.
I have root 29.
Okay, I'm just writing the formula first. so that everyone can see how we got there. X2, let's say T is 2, S is 1. X2 will be our 3, X1 will be our 5, Y2 will be our 7, Y1 will be our 2, all squared. What is the answer?
Root 29.
Root 29. And then sine of angle R will be root 29 over root 145. Is it hard?
So you are taking, yeah. You
Sorry?
help. That's why you're helping us.
Oh, we are left with the 2 questions now, so we can expect hell in those 2 questions, back and forth. But it will give us hell, we will give it solutions. Let us show that let us show that B is equal to that expression. B is equal to that expression. So where is B and A? There is B and A.
The tangent.
Yeah. There is B and A in that tangent. And if you look at that expression, it looks like a
straight line.
A straight line something. Yeah, a straight line something. So which equation of a straight line should we calculate if we want to determine B in that expression? Which equation of a straight line should we calculate?
TK.
Yep, we should calculate the equation of the tangent, which is LK or TK. We should calculate the equation of the tangent. Do we have the equation of the tangent? Do we have the gradient? I mean, sorry? Do we have the gradient?
Yes.
What is it? Are you sure that we do?
5 when we found it.
5
over 2. Negative 5 over 2.
No, I mean the gradient of the tangent, not TS.
No, so we don't have the gradient, but we can calculate it.
Yeah, we can calculate it. Why do you think we can calculate it?
Because we have a diameter that is perpendicular to the tangent.
Excellent. So you're then going to use the gradient of TR in order to get the gradient of the tangent. So our first task is to determine the gradient of that tangent, which is quite an easy task. Gradient of TR y2 minus y1 x2 minus x1. So let us say that is 1, that is 2. And then that means y2 is 6, y1 is 7, x2 is 15, x1 is 3. What do you get from your calculator?
I get a negative 1 over 12.
A negative 1 over 12. So we said when we want the tangent, the gradient of the perpendicular line, let's say TK in this case, we are going to first change the sign of that gradient.
I also got negative 1 over 2.
Okay, so what will be the negative of the, no. What will be the gradient of TK?
It's going to be 12.
Yep, it will be 12. We change that negative to a positive, and then we switch things up. 1 becomes a denominator, 12 becomes a numerator. 12 over 1 is just 12. And then we determine the equation. Minus, what is y1? What is y1? Which point are we going
7.
to use there? 7, yes.
Oh, I've been shouting. I thought it was unmuted.
Yeah. X minus 3, and then we say y is equal to 12 times x, that is 12x. 12 times 13, 12 times 3, I think that is 36. And then plus the 7 that is on the left. Well, was on the left. 12x. I think you should get a negative 29. And then we have a point K, which is A, B. In the place of Y, we substitute B. In the place of A, in the place of X, we substitute A minus 29. Is it hard?
She said,
hello?
The fire is here now.
So you haven't felt it so far?
The fire is coming. You can feel the radiation.
If you say it's coming, that simply means you have not felt it so far.
So you can feel the cramps.
So that means you are comfortable with how many marks? 17 marks out of 23. Out of these questions, you're comfortable. You're comfortable with 1, 2, 3, 4, 5, 6, 7 questions. Let us see how the last one goes. Very last one. And then we say goodbye to each other. We say goodbye to each other. 6 marks, this one. It's going to be interesting. They say that if TK is equal to PR, if TK is equal to TR, there is TK, there is TK, there is TR. Oops. They say if these two lines are equal, remember that angle over there is 90 degrees. Maybe we will need that, I'm not sure. Then calculate the coordinates of K. Very interesting. I wonder where does the distance get into when it comes to a straight line, because as far as we know so far, when it comes to A and B, we have their expression in a equation of a straight line. So now they say TK is equal to TR, then calculate the coordinates of K. This shouldn't be so hard. This is nice. Because you see, when they talk about one side being equal to another side, once they give you that, that means your hint has to revolve around what? Is it around a gradient, around the midpoint, or around a distance, which one do you think you will use?
Sir.
Sure.
Wait. So we know that TK is equal to TR. And we know that the
TK
angle
is equal to TR, yes.
And we know that the angle side, the angle R is equal to yeah, whatever it is. Coordinates of I don't know. No, I don't know.
You see, when they tell you about one side being equal to another side, what makes you see that this side is actually equal to that side? Do you use a gradient? Do you use a midpoint, or do you use a distance formula? Which one do you use out of the three?
To determine if a line is equal to another.
Yep.
If
you want, sorry, it's not gradient. Definitely not a gradient.
It's
so we
distance.
have yep, it's a distance formula. So now we are told that this line TK and that line TR are equal. That means somehow we might want to use something that has something to do with the distance formula. Yeah. But we will see. So that will be the distance of TK or the distance of TR or both.
Okay, let's go.
So let us calculate the distance of TK. Can we calculate it?
Yeah. So we do square root 145.
The distance of what?
TK.
Oh, we have calculated the distance of TR. Nice.
Yeah.
So the distance of TR is square root
145
of 145. Oh, that becomes way easy. So now when we have the distance of that, we will say the distance of TK, this is the distance of TK, is equal to that distance formula. X2 minus X1, Y2 minus Y1. What are we substituting here?
145. Root 145, yeah.
Root 145. Now we have to, because the points that we are going to use is T and K. Let's say point 1 is T and point 2 is K. So what is the X value at point 2?
A.
It is A, correct. What is the X value at point T?
3.
3, correct. What is the Y value at point 2?
B.
Correct. Minus what is the Y value at point 1?
7.
Correct. And then you see that there are a lot of squares here. How can we remove squares? Square roots, I mean.
By brackets squared.
How can we remove these squares? This square root and that square root?
By squaring them.
Hello?
Not you. Hello?
How do we remove this square root and that square root?
I said you put brackets squared.
Yeah, you put brackets and then you square it. You put brackets that would be 7. And then you square it. So you will be left on the left with 145. And then on the right, you will be left with A minus 3 squared plus B minus 7.
squared.
So far, so good, né?
Yeah.
Yeah.
Okay. Now we can replace that B with what?
The formula.
Wow.
Oh, you see, you get it now.
Yeah, 12A. Okay, but they didn't say hands most. So
Hey, my man, you have to use everything that you have determined on the previous questions.
yeah.
It's a very good thing that you are like now, oh, that's a very good thing. So we will substitute in the place of B by 12A minus 29. 145 A minus 3 squared. In the place of B, 12A minus 29 squared. And then everything else is just algebra. What do you think we should do?
Fix our brackets first.
Yeah, clean the interior of the brackets.
Yeah, and you forgot the.
Oh, I forgot. Yeah. No, I was just checking if you guys are awake. That's all.
Ah.
That's all. So minus 27, minus 29, minus 9. I think that will be minus 36. And then everything else flows again. We should multiply this one out, right?
Yes.
And multiply that one out. So the first one I think is a little bit easier. A squared minus 6A plus 9. Are you able to see how did we get here? Do you understand how we got here?
Yes, we multiplied out the brackets.
Yeah, I multiplied out A minus 3 to the power 2, which is A times A, minus 3A, minus 3A, which gives minus 6A, minus 3 times minus 3, which is positive 9. This one will be a little bit challenging because it has some coefficients and big numbers. So can you determine it on your side?
Yeah.
What do you get?
Wait. Oh, this is a lot of numbers.
There are. It should be 12A minus 36, 12A minus 36. What is 12 times 12? Is it 144?
Yeah, 144A squared. 864
squared. You are giving me the final answer, right?
Yeah.
It's 144.
Yeah.
A squared.
A squared, yeah.
Okay.
Minus 864A.
Is it 864?
Yeah.
A
plus 1,296.
Big numbers. So let us then clean this out.
Like terms.
Collect like terms and everything. So we will be left on the left hand side with a 0 because we will take that 145 to the right and it become negative. Are we okay with that one? So we will have 145 A squared
minus 864
minus what?
Minus 878
minus sorry, minus
plus 1160.
Whoa. Why is it 145 a squared?
Because the a's.
Oh, then the a's add together. So my bad.
Is this right? 870A? Yeah, I think it is. When you write the constant now, you should add 9, add the 1,296, and subtract that 145. Did you subtract it?
Yeah.
What did you get?
1160.
And then this is a quadratic equation. You can say A, it's a quadratic equation, A, which is minus B plus or minus square root of B squared minus 4A. Well, it's a little bit confusing.
Yeah.
Because, yeah, A, this A, in this case, this A is not that A. And this B is not that B. Yeah, A is that 145.
Yeah?
B is that negative 870.
Yeah.
And then C, it is that negative 1160. So let me clean that out.
I get x is equal to 4.
Or A is equal to 2.
Or x is equal to 2.
A, not X.
Same thing.
Not X.
Potato.
It should be A is equal to
4 or
negative.
A is equal to 2.
Our B is negative 870.
Yeah, this is long.
Plus or minus. Minus
Plus
4. What is our A? 145.
145.
What is our C? Minus 1160. All divided by 2A. 145. So you get that A is what?
A is 4.
Okay.
A can't be 4.
Or A is 2.
A is 4 or A is what?
2.
2. Which one is this one?
So we take the A is equal to 2. We cancel out A is equal to 4.
Why do you cancel 4?
We sub it back into the formula.
And then when I sub it 4, I got to 19 for Y. And it doesn't correspond with my readings of the graph because B is on the negative side. So it has to be minus 5.
Absolutely correct. So let us substitute. B is 12, 4 minus 29. What do you get? What do you get for this one on the left?
19.
19. B is equal to 19. What do you get for the one that is on the right?
Minus 5.
Minus 5. You see now, this is where it comes in. Now, you remember when they told us that K is a point in the fourth quadrant?
Yeah.
That is why they told us that thing. Now it comes into playing. So when you write the coordinates of K, you should expect A to be positive, B to be negative. So you will take the B that is negative alongside with the A that gives you that B. So that will be 2 and a negative 5.
Ow.
And that is the end of our. That was nice.
End of the
Really
journey.
nice. Yeah.
Thank you very much.
Yes,
Yeah.
easy, man.
Yeah?
Let me go eat some honey.
Yeah, let's go and eat now. I'm hungry as well.
6,
It has
7,
been
6 colors, 7
yeah.
colors. Sunday.
Hey, you're discussing meals now. Hey, this guy.
Yeah.
Thank you very much, sir.
Thank you very much, sir. You helped us a lot. Yeah,
No problem, sir.
very much appreciated.
Yeah, thanks, sir.
Thank you. No, I haven't seen your faces. Come on. Switch on your cameras and let me see. Who am I talking to?
Sir. Okay, let's switch on the cameras.
You cannot.
My camera's on.
Oh, wonderful. I can see you.
Can you still see me now?
Yeah, I can.
Yeah, thanks, sir.
No, salute, my man. Who's the next one?
Wait, I'm coming.
He's coming here.
Oh, you guys are having a study session here.
Yeah.
Salute, my man.
Together.
Thank you, sir.
Thank you very much, sir.
That's good. Sure. Salute, gents. Sure.
Dango!
Danko.
Sir, may I ask?
Sure.
What program is this?
It's a program that the Wesley kid came up with. Let me.
Like the church?